To configure enhanced vMotion compatibility, you need to edit the settings of a cluster to enable it. There are two methods that you can use for doing this, as EVC cannot be enabled on an existing cluster unless all VMs in the cluster are shut down. The first method is to create a new cluster that is enabled for EVC and then move your ESX host into the new cluster. The second method is to shut down all the VMs in your current cluster or migrate them out of the cluster to enable it. The first method tends to be the easier way, as it does not require any VM downtime. If you choose the first method, you can simply create a new cluster, then move your hosts one by one to it by first putting it in maintenance mode to migrate the VMs to other hosts. Then once the host is moved to the new cluster, you can vMotion the VMs back to the host from the old cluster to the new one. The downside of this method is that you have to reset up your HA and DRS settings on the new cluster, and you lose your cluster performance and migration history. Once you have enabled EVC on a cluster, only hosts with compatible CPUs will be allowed in the cluster. Let's now look at a demonstration of enabling EVC on a cluster. Okay, we're now going to show you how to enable EVC. As I'd mentioned, there are two methods for doing this. The first method is to create a new cluster that's enabled for EVC, and then move your ESX host into the cluster. The second method is just to shut down all the VMs in your current cluster, and then enable EVC on the cluster, then power them back on. So we're going to show you that method first. So our cluster here, we can see all the VMs in the cluster are currently powered off. So now we're going to edit the cluster settings. Select VMware EVC. You'll see it's currently disabled, so we go down here and click the change button. Now, depending on if you have AMD host or Intel host, you're going to select an option. Our hosts are Intel based, so we select Enable EVC for Intel hosts. Then you get a VMware EVC mode, and this is basically the baseline feature set that's going to be presented to all the VMs. It's all going to be based on this one process that's selected here, the Intel Xeon Core 2. There are a few other types that you can select, so basically just select one that's listed and stick with it. Now once you enable this, only hosts with that processor type and that processor family will be allowed into this EVC cluster. So now we say OK. Say OK again. And that's it. Our cluster is now configured for EVC, so we can start powering our VMs back on. Okay, we're now going to show you the other method where we're going to create a second cluster, and then we're going to shut down one host, move the VMs, before we shut it down, move the VMs to the other host, shut down a host, put it in maintenance mode, remove it from the one cluster, add it to the second cluster, power it back on, and then move the VMs from cluster A to our new cluster, and shut that host down, move it to the second cluster, and then power it back on. And once we're done, we can remove the original cluster. So to do that, we're going to select and add a new cluster. So we call it cluster B. Now you're going to have to reset up your cluster features like HA and DRS. We're just going to leave them off from right now, and we can turn them back on later. Here's when we enable EVC. Our hosts are Intel hosts, so we select Enable for Intel. The VMware EVC mode, we're going to stick with the Intel Xeon Core 2. Click Next, and click Finish, and that creates our new cluster. So now we have a cluster A and cluster B. Now, both of these hosts currently have a running VM on them, so what we're going to have to do is move one host at a time. So to do that, we'll first take the VMs that are powered on, use vMotion to move them to the other host, and it's now going to move that VM that's running from silver to gold. And now once that happens, you're going to have to, if the VMs are not on shared storage, you're going to have to power them off and cold migrate them, or just leave them powered off. So once all your running VMs that are on shared storage are moved to the other host, you can then shut that host down and move it to the second cluster. So that's complete. we now have no running VMs on this host, so we're going to put it in maintenance mode. So yes, and we don't care about moving powered off or suspended VMs. When we put it in maintenance mode, it disables the HA agent that's running on that host. So it's doing that, and then once it completes, we can remove it from cluster A and add it to cluster B. That's complete. So now we do a remove. And there's a warning that says it's going to remove all the virtual machines, which we're okay with that because it's going to re-add them to cluster B when we add to that cluster. So when you remove a host from a cluster from vCenter, it basically uninstalls the vCenter agent from that host. And once we add it back to a cluster, it'll reinstall that. So now we can see that host is completely gone. So it's gone but not forgotten. So we put it over here, cluster B. Now we do add host, enter the host name. Enter the credentials to log into that host. Say yes for the warning. You can see the virtual machines that are already on that host will automatically be added to the inventory of vCenter server. Assign a license. And that's it. So you can see there now that that host is being added to that new cluster. It's installing the vCenter agent on that host. And once that completes, it's going to be up and running. And our VMs will show back up. And there they are. So that host is still in maintenance mode. So we want to exit maintenance mode now. Select that option. And that's complete. So now we go back to our original host, and it's got two VMs on them. They're both running on shared storage, so we can use vMotion. So these VMs are going to stay up the entire time that we're doing this process. So we're going to use vMotion to migrate them to our new cluster in the host over there. We're going to say change host, select cluster B in that host. And there goes the first VM. And that VM is completed. Now we select the second VM, do the same thing. Migrate. Change host. Select the second cluster and the host in that cluster. And it's beginning the vMotion now to move that VM. Now that's complete. So all of our running VMs have moved from cluster A to cluster B to that host over there without any downtime at all. So now to complete this, all we need to do is all the VMs here are powered off. So now we just enter maintenance mode here. And it's disabling HA on that host. Once it completes, we'll remove it. Okay, it's in maintenance mode now, so we can remove it. Say yes. So now it's going to uninstall the vCenter agent from that host. And that server is gone also. So now we want to add it to cluster B. Select add host. Enter the host name. put in the credentials to log into that host. Select next, ignore the warning. And you see all the virtual machines are still on that host, they're intact. Assign a license, click finish. And it's installing the vCenter agent on the host. Once that is completed, all the VMs will be back. And there you go. It's in cluster B. So now we want to exit maintenance mode. And that's complete. So now we can get rid of cluster A. There's no VMs in there anymore. Or optionally, if you want to preserve the settings that were in cluster A, now that the hosts are moved out of cluster A, you can go back in there and enable EVC on that cluster, and then just reverse the process to move these hosts and VMs back to cluster A. And that way you can preserve the HA and DRS settings, as well as the performance history, statistics, and all for that stuff. So either way, we're simply just going to remove this cluster A. And that's it. Now we have one cluster. Now if you want, you could also rename this cluster back to cluster A. We're just going to leave it the way it is. And that's it. That's all there is to enabling EVC. In vSphere, storage vMotion is no longer tied to vMotion. It is licensed separately and does not require that vMotion be configured to use it. So no extra configuration is required to configure storage vMotion, and it can be used right away as long as you meet the requirements for using it. In VMware VI3, you needed to use a remote command line utility called svmotion.pl to perform a storage vMotion. In vSphere, this is now integrated into the vSphere client. However, you can still use the svmotion.pl utility that is part of the vSphere CLI to perform a storage vMotion. To perform a storage vMotion in the vSphere client, select the VM and choose Migrate. When the migration wizard loads, you have three options to choose from. The Change Host option performs a vMotion. The Change Data Store option performs a storage vMotion. And the Change Host and Data Store option performs a cold migration for which a VM must be powered off for. Select Change Data Store and then select the destination data store from the available list. If you choose the same destination data store as the source, nothing will happen. If you want to change the disk format or reshrink the disk, you must move the VM from one data store to another. You can then move the VM back to its original data store once it completes. You can also choose the Advanced option to move the configuration file and virtual disk to different data stores. Once you select the data store and the validation checks are run, you can choose a disk format. Here you can choose the same disk format, or you can choose a thick format to convert a thin disk to thick, or choose a thin disk format to convert a thick disk to thin. Once you click Finish, the process will begin. This can take quite a long time based on the size of the virtual disk, the format you choose, and how busy the host is. Let's now look at a demonstration of performing a storage vMotion. I'll select the VM, and right now this particular VM is on the local data store. We're going to move it to the shared data store. So we're first going to take a look at the virtual disk of this VM. You can see that it's a 10 gigabyte thick disk. So to initiate a storage vMotion, we right click on it, select Migrate, and we want to do the Change Data Store option, which is for storage vMotion. Change Host would be for vMotion. So we select that option, and we're going to select our shared data store here. The validation succeeded. Click Next. Now here's where we can change the disk format. Right now it's currently in a thick format. If we wanted to convert that to a thin format, we could simply select Thin Format. Or we could just leave it the same format as the source, which is already thick. We're going to leave this one as thick. Now, one thing to note is if you just simply want to change the format of a virtual disk file, you can't do it to the same data store. You have to pick a different data store to change that disk format. And then once you move it to the other data store and the format changes, you can move it back to the original data store using that same format, and that will complete. If you have just one data store, you can't really use storage vMotion to change the disk format. So we're going to click Next here. Here's just a little summary of what's going to happen. The host is going to stay where it's at. It's going to move to the new data store at a default priority, and the format will be the same as the source, which is thick. So we click Finish, and there goes the task. Now, depending on the size of that disk, it can take quite a while to move it from the one data store to another. If it's a very large disk file, it can take actually hours for it to move. But depending on how large the disk file is, it can take anywhere from 10-15 minutes all the way up to a couple hours. That'll really depend on a couple different factors, like how busy your network is, how busy your storage is, how busy your host is for when this process is going on. So that's basically it for storage vMotioning a VM. Here are some tips and best practices for using vMotion. First, it is a recommended security practice to put your vMotion network traffic on its own isolated network so it is only accessible to the host servers. The reason for this is twofold. First, vMotion traffic is sent clear text and it is not encrypted, so isolating it ensures that the sensitive data cannot be sniffed out on the network. Secondly, it ensures that the vMotion traffic experiences minimal latency and is not affected by other network traffic, as the vMotion is a time-sensitive operation. Using vMotion with VMs with running snapshots is supported as long as the virtual machine is being migrated to a new host without moving its configuration file or disks. It's very important to ensure that the vSwitch network labels, also known as port groups, are identical, which also includes case, across all your hosts. If they are not, then you cannot vMotion a VM between two hosts that do not have the same network labels configured on their vSwitches. In versions prior to ESX 3.5, virtual machines that had their virtual swap file not located on shared storage could not be moved with vMotion. The reason for this is that the destination host would not be able to access the virtual swap file that is located on the source host's local disk. Beginning with ESX 3.5, support for using vMotion on virtual machines that have local virtual swap files was added. If a VM with a local virtual swap file is vMotioned, then the file is recreated on the destination host, and the non-zero contents of the file are copied over as part of the vMotion operation. This can cause the vMotion operation to take slightly longer than normal due to the added virtual swap file copy operation, in addition to the normal CPU and memory state copy operation. Using a local swap file data store can be advantageous as it frees up valuable and expensive shared disk to be used for other things like snapshots and virtual disks. Here are some more tips and best practices for using vMotion. There are many possible compatibility error messages that you may experience when performing a vMotion. See VMware Knowledge Base article number 1003684 for information on what all the messages mean so you can resolve them. It is possible to mask some of the host CPU features using a CPU compatibility mask in order to allow vMotions between hosts that have slightly dissimilar feature sets. These masks can be set individually on each VM by editing the VM's advanced settings, or you can globally set CPU compatibility masks on the vCenter server instead. See VMware Knowledge Base articles number 1991, 1992, and 1993 for more information on how to set up these masks. Here are some tips and best practices for enhanced vMotion compatibility. If your vCenter server is running as a VM on the cluster that you wish to enable it on, this can be a bit tricky, and there are some extra steps involved which are detailed in VMware Knowledge Base article number 1013111. Here are some tips and best practices for using storage vMotion. Storage vMotion can be used to automatically correct VM file name mismatches for VM files that do not match the VM name. This can happen when you rename a VM in the vSphere client. Normally the VM file names and the VM home directory all match the name of the VM. If a VM was named Diamond, most of its files will start with the Diamond name and have different extensions. An example would be diamond.vmdk for the virtual disk file. When you rename a VM, these files do not get changed and the new VM name is linked to the old file names. If you perform a storage vnotion to another data store, it will automatically rename these files and the directory for you to match the new name. You can then move the VM back to its original data store if you desire. In addition to using the vSphere client to perform a storage vmotion, you can also use the smotion.pl utility that is part of the vSphere CLI to perform a storage vmotion. If you wish to reshrink a thin disk after data has been deleted from it, you can use the Microsoft sdelete.exe utility, also known as secure delete, to zero disk blocks that were previously written to, and then use storage vmotion to reshrink the disk and reclaim extra space on the data store that was used. This utility is available from Microsoft's website. Once you download it to the VM, you can run it by selecting sdelete-c and specifying the drive letter. Now this zeroes disk blocks on the drive inside the OS, and because of the method it uses, will cause the thin disk to grow even larger while the operation is occurring. It can also be fairly resource intensive on the VM. Once it completes, you can use storage vmotion and specify thin disk format to reshrink the disk with the newly zeroed space, which will make it much smaller. However, you must specify a different data store when you do this. Once it completes, you can move the VM back to its original data store. You can also use storage vmotion in combination with vmotion to move a VM on a local disk of one host to the local disk of another host while it is running. To do this, you first use storage vmotion to move the VM to shared storage, then use vmotion to move it to another host, and finally use storage vmotion again to move it back to the local storage on the new host. Here are some links that can assist you with CPU compatibility issues with vmotion, as well as show you how to set up CPU masks to override vmotion CPU compatibility. Additionally, these links will help you with enabling EVC on a cluster when vCenter Server is running as a VM. vMotion is one of the best features available in vSphere and is the enabler to other features like DRS. Once you have used vMotion, you will find out how valuable a feature can be in certain situations. Storage vMotion is another amazing feature that gives you the flexibility to move VMs around on data stores while they are running. In this lesson, we have learned how to set up and configure vMotion, enhance vMotion compatibility, and storage vMotion, and also understand how the features work and how to deal with the requirements that they have. That concludes this lesson on vMotion and storage vMotion. Thanks for watching, and I'll see you in the next one.